I guess we can get started. Um, so I guess as a way of kind of segueing into this talk, the thing I'm going to tell you is that I have this hobby that I'm not all that proud of. Maybe I am. I go around the world and I annoy developers. Okay? Um, and I don't do this intentionally, or maybe I do. I don't know. There is a little. You ever get some joy out of annoying somebody? It's one of those things where it's like, it's not something to be terribly proud of. But if you have a point to make sometimes, annoying people is a way of going and getting them going and thinking about something they wouldn't be thinking about otherwise. So the way that I annoy developers quite often is I talk to them a bit about testability, and then I start going and saying things like, well, if you wrote your code better, it would be more easily testable. And then they go and they counter with, well, yeah, but then I would be basically putting the tests in control, and I wouldn't really be able to do exactly what I want to do because I'm the smart guy, right? I know how to design classes. I know how to go and create systems that tie together, and I've got all this design skill I've built up over years and years and years. And when I point at some design that they've got and I say, well, this isn't really testable, they're kind of like, okay, so what? I know I'm a good designer, right? And I say, no, you're not a good designer. If your code isn't testable, then that isn't a good design. And that really irritates people. It really does. I mean, people get really, really deeply irritated at this sort of thing. And, well, I can't say that I don't enjoy some of that a little bit, too. It's really something that I feel very strongly about, and I felt strongly about for years. So I'm taking the opportunity of this conference to go and talk about this particular topic. It turns out, as the slide says here, that there's a deep synergy between testability and good design. And it isn't just that thing of going and saying, well, if you look at a design and you can say, well, it's like, yeah, sure, if you can't test it, it's like, how do you even know whether it's good? It's way deeper than that. What it comes down to is that many of the fundamental things that we do to make design better also tend to make it more testable, okay? And so if you're coming up against a design where things aren't really all that testable, chances are you can find some design problem. In fact, I believe that as a bet. It's kind of like if you show me some code that isn't testable, and I can come back to you and say, oh, yeah, well, you're right, but there's no design problems, then, I lose. I'm not going to put any money on that. But in general, I think this is true. Essentially, every time you encounter a testability problem, there is an underlying design problem. So that's what this talk is about, kind of digging into this particular thing. So I want to start out with a bit of an example. Okay? So everybody knows that there's all different kinds of classes in the world, right? People create all different kinds of classes to solve various different problems in software development. They design them well, they do various things. There's different types of classes. This is one I call an iceberg class, okay? What I mean by this is a class where most of the mass is underwater, kind of like an iceberg. You've heard about icebergs, and they say like about 20% of the mass is above the water, and the rest of it's like way down below. What I mean by that here is that we have one public method, we have all these private methods. Anybody have any classes like this at all? Yeah, I mean, it seems like a decent thing to do because, you know what the public interface is, you know what clients are going to have to go and use, and then you've got all these other functions that you really don't want them to touch because they're basically calls down from the public method. So evaluate here goes and calls parse adjunct term calls call factor term, parse adjunct, and it just kind of goes and trickles down. This is really kind of like a recursive descent parser built inside of a class. So you have this sort of thing, and it seems like a decent design, right? Well encapsulated and everything like that. Until you get to an interesting thing. You look at this and you say, wow, I want to write some tests for this. And it seems like it should be easy enough to do, right? You've got a public method called evaluate, pass a string to it, form the string well, find out what happens. And you just do that over and over and over again, and you should be able to kind of hit all the code that's in there. If you can't hit all the code inside the class through that public method, it's just dead code. But the thing about that, though, is that sometimes that's kind of frustrating. You look at this, and you say, wow, there's that get next token method, and there's that has more tokens method. And it's like there's something about that particular method I want to understand better. And I would understand it better if I was able to write some tests for it, if I was able to go and just sort of take that by itself and write tests to see exactly how it works under various conditions. So what do you do in this case? Well, if you're like many developers, you just start to complain. You're kind of like, oh, okay, this testing thing is not all it's cracked up to be, okay? Testing private methods is hard. Why do I have to test this code? Oh, I know why I need to test this code, but why is it so at odds with what I want to do? And then you start thinking about it, and you think, well, gee, one way around this is I can essentially go and make that method public. So I made has more tokens public over there. Is that a good solution? Well, you needed access to it, right? Although it does look kind of weird, right? You're looking at this class, and typically when we see things in the public interface, we're seeing things that we expect people to be able to go and use. We expect them to basically use this in a natural production situation. But here, we want to go and increase the visibility just for testing. Nice? Bad? Wrong? Well, there's this whole area of tools that's kind of cropped up to solve this problem. Okay, you can basically do all sorts of little fiddly things within the .NET runtime and within the JVM and stuff like that to go and gain access to private methods and do various things. So technically the problem is solved, right? You just have to go and use a tool that gives you special access. You can dig in and you can go back and just keep your class nice and pristine the way you expected it to be and march along, but test the individual pieces that you care about. Is that okay? Well, it's funny. It looks like you've got a hard problem, so you get a tool and you use that tool to go and solve the problem. Problem's gone. But the thing to point out about this, though, is that really, aren't there problems with this class already? Are there any problems with this class? It looked good, right? But what about this? Remember the single responsibility principle? Anybody ever hear about this at all? The notion that a class should have a single responsibility, should do one thing and do it well. It should have one axis of change within it. How many responsibilities does this class have? Well, I'm pointing at one right now, okay? We have the evaluate method. So one of the key things that this class does is it goes and evaluates a string. And that's what it looks like it's doing from the outside world. So it's doing this piece, but then it's kind of like if you look deeper and you dig into it a bit more, you discover that, wow, it's also doing all this parsing stuff. And for us right now, it's pretty obvious that it's doing this because we have the prefix parse in front of all these methods. So is parsing the same thing as evaluating? Not really, right? Two different things. Next thing also, we dig down and we have has more tokens than get next token. Okay, so these are not quite the same as parsing. It's parsing at a different level. It's kind of like tokenization or making a lexer, for instance, a special purpose lexer for these things. So technically we can say, yeah, this is all kind of under the rubric of going and evaluating a particular string, evaluating a rule. But we are doing these three distinct things. And we should not be surprised to go and notice that if we looked at like a graph of what uses what inside of this class, we probably discover that there's particular distinct areas of use. The evaluation stuff is over here. The parse stuff tends to call into itself. And then it calls into the tokenization stuff, which is kind of off by its own also. So the class has this problem already. So what if we go and we look at it a bit deeper and we say, okay, we have our rule evaluator. Why don't we go ahead and do an extract class? So we end up with this. We have a rule evaluator and holds onto a rule tokenizer. Look at the visibility of the methods that we have on the rule tokenizer. Those are all public now. Easy to test? Yeah, generally, right? You have something you can, some interface you use to go and pass a string into the tokenizer. You can go and ask whether you have more tokens. You get the next token. You can do various things. And it's all public, but it doesn't bother us at all because when we hold on to a rule tokenizer inside the rule evaluator, we're holding on to it as just a private member. And it's hidden from our clients. But the rule tokenizer interface itself is public and thus visible to our tests, and we can go ahead and test the things we want to independently. So I go around to people and I tell them, when you have this situation up here and you really want to go and start to test some of that other stuff, you've got a problem in your design. And then they say, well, yeah, sort of. And then I show them this, and they're kind of like, yeah, but I don't want my test telling me what to do. My test shouldn't be telling me what to do. But the thing you have to kind of recognize is that these things do really point at real design problems. Is this a better design than the one we saw previously? Well, we got to go and decide what better is, right? Okay, we do have principles we can use to go and guide us. Single responsibility principle, dependency inversion principle, open-close principle, all these other things that we tend to know are good for design. Many of these things really when we go and adhere to these things well, we end up with more testable designs. One objection to this, people often look at this and are kind of like, well, if you do this, you can have lots and lots of little classes. Anybody ever feel that way when they look at this kind of stuff? You're going to get lots and lots of little classes. Is that bad? It's different. I guess that's the main thing to go and point out. And this is a really interesting thing about software development and software developers in general. Often people who first get into software development, they start feeling like, well, it's like I just need to go and write the code to go and solve the problem, and my methods tend to be a little bit bigger. I have a class that exists already, I can put this method on, so I add the method to the class and stuff along those lines. But as you start to go and adhere to this single responsibility thing, yeah, it's true, you have to do a little bit more navigation to get to what you want, right? When you get to the rule evaluator, you're asking yourself, gee, how does tokenization happen? And you've got to jump to another file that has the rule tokenizer. And when you jump over there, you're able to go and sort of see what happens with that. And maybe if our design is factored a bit more, we'd have to jump to yet another class. But the thing is that since each of these pieces has a single focus, it tends to make maintenance a bit easier because we can replace and swap out particular pieces and not worry so much that things that we're doing in the rule tokenizer are going to impact things that happen in the rule evaluator all that much. Okay? So it's a general maintainability thing. And as you go on in software development, what you kind of discover is that having the small pieces is useful, even though it's a bit more navigation to get to them. So it is. These are things that kind of align with good design. So this is the thing that I think is really the key thesis here. Solving design problems solves testing problems. And I think the thing that's really kind of funny about this is that it's taken me a long time to go and really kind of understand why. This right here, if we did this, we just chose to go and make this particular method public. Does that go ahead and make our design better? It's a way to solve a testing problem, right? But making code testable does not necessarily make the design better, right? So there is this confluence between testability and good design, but it does have a direction to it. Making design better tends to make things more testable. But there are ways of making things testable which aren't necessarily adherent to good design principles. So there's a deep synergy here, and the thing is I really think that we don't appreciate why this is true. I think to the degree that we appreciate why this is true, it's really easier to go and sort of take that advice that if making the design better does make testing easier. So let's talk a bit about some of those things, some of the things which make testing difficult and the related design problems. And then we'll talk a bit more about why this synergy occurs. So testing pains. State hidden within a method. You ever had this situation at all? It's kind of like you have a long method, and it's kind of like, what you'd really, really like to do in a particular situation is just write some tests against local variables. Because your method is so long, it's kind of like you want to do like an extraction or something, or you want to modify things, and like you're just asking yourself, what's the value over here? Sure, you can hunt through with a debugger and find out what the value is there in a particular case, but it's kind of like if you're able to write tests against those particular bits of state, you'd be able to go and understand your code a little bit deeper, okay? So that is something which tends to be kind of painful in a testing situation. Does it point to a design problem? I don't know, how many people enjoy long methods? You think they're great? Nobody, cool, great audience, okay. Some people will argue and say, yes, it's all on the same page, I can see everything together and that sort of thing. But really, that points to a simple problem. The methods are too long, and typically, whenever you have a method that's beyond, maybe 5, 10 lines, you have more than one responsibility. And if you look at it, you'll discover what that responsibility is, what those responsibilities are. And detangling those things tends to go and get you smaller methods. So have you ever seen a method that's like about 20 lines long that has only a single responsibility? Only cases I can think of are things like data initialization or something like that. But for the most part, once you start getting code in that range, you have things you can separate out. You have things that you can make orthogonal and break out into other pieces. And if you tackle that design problem, then this particular testability problem just goes away. Difficult setup. Anybody ever have this trouble with testing? Yeah, I see a couple of hands, right? Which, what that tells me? It means you're writing tests, right? I mean, it's just, I know people didn't raise their hand. I know you're writing tests too, okay? But the deal is that this is a very, very typical problem in existing code bases that don't have tests. You're sitting there and you want to go and basically get one particular class under test, write some tests for some of its methods in order to go and solve some problem, and then you're kind of like you're going through this big, big detective work job of going and figuring out how you actually instantiate this damn object, right? And it seems like it shouldn't be all that bad because you've got a constructor, right? So you go ahead and you create an instance of this thing in the test harness, or you try to create an instance. And then you discover it's like, okay, well, my constructor accepts 3 arguments. It's like, okay, that's pretty cool. And then you look at it and you say, okay, well, then I'll create those other objects. And then you dig down a little bit deeper and you discover that those other objects take other objects and take other objects and take other objects. And you find yourself kind of bringing half the application in just to instantiate one object. Now, we know that there's ways around this. Your constructor accepts certain arguments. Maybe if those things were interfaces rather than classes, you'd be able to create a mock and put them in and stuff like that. But the thing is that that particular pane itself should tell you something about the design. It doesn't mean that this class is doing work that is so complex that it needs those 12 arguments. What it means is that people did not factor that class into smaller pieces with fewer dependencies. And you can always do that, okay? I don't care how complicated your problem is. You can always arrive at smaller classes that solve that problem rather than having a big gargantuan one with many dependencies. So for this particular one, difficult setup, essentially the issue is too much coupling, okay? You have a class that depends upon way too much. Now you can see this stuff in code, right? You can look at classes and you get a sense that you have too much coupling sometimes. But when you start writing tests, it turns into concrete pain. It turns into this thing of like, well, I want to write a test, but I can't really write the test. Okay, well, yeah, I can write the test. It's just painful. It's going to take me 15 minutes to hunt through all these dependencies and create all the things that I need to pass them into this particular thing. So there's a big difference between mentally knowing about coupling and feeling the pain of coupling, right? And I think that this is one thing that we can kind of learn from testing in a sense. That there's lots of things we can say, that's bad, and we kind of dismiss it and not think about it. But when we actually write tests, we feel concrete pain. The concrete pain is not because testing is difficult, it's because we need to change our design. Incomplete shutdown. Okay? This is one which is kind of subtle, and sometimes people don't run into this at all. Okay? But I run into it quite often in large applications. Sometimes you have an application, it isn't really a server-based application, but it's something where, it comes up and people work on it, and they do their work through the application and everything. And then they bring down the application, and everything seems normal, except if you keep the application running for a long time. And then you discover that you have all sorts of mysterious things happening because you're leaking resources and all these other things. And what's funny about this is that some of that stuff can be kind of baked into the design. It's like you really aren't going and getting rid of certain resources and stuff like that. And you're not even really aware of it because you bring the application down and the runtime just goes and takes care of those things for you. Now, one of the things that's funny about writing tests is that you are taking individual chunks, and those individual chunks, they should clean up after themselves. You're trying to go and take those chunks and bring them under test. And if they don't clean up after themselves, quite often they can cause side effects in the rest of the test that you have. So I've seen this a number of times. You go into a shop, and you go and you start saying, it's like, wow, I'm trying to go and test this particular piece of code, but guess what? It never cleans up after itself. It never goes and releases all of its resources. And then you discover later on, it's like I'm running a suite of 2,500 tests, and things start hanging because I'm not really releasing all the resources that I care about. So this is really a big deal in many C++ programs. Application comes up, you bring it down, and you're not really even aware that you have resource leaks and things along these lines. And the thing that's nice about this when you're working in a testing environment is that you are forced to go and produce a bit of discipline for what you're working on. It's kind of like if you really are leaking resources, you're going to discover it rather quickly. If you aren't doing the proper cleanup that's going to go and affect other things and other tests, you are going to find that out rather quickly. So as a result, you end up having classes which tend to take care of themselves better. And is that good? Yeah, it's generally good. I mean, we want classes to be able to go and take care of themselves. What I think is interesting about this is that, again, we can tell this thing with our design thoughts. We can look at a class and know whether it's taking care of itself well or not. But the thing is, writing tests for things makes it a concrete pain. It makes it a concrete issue that we have to go and deal with. And reminds us, as we're developing our software, that this is an important and good thing. Is anybody starting to feel kind of spooked right now? Like this is strange magic? It's kind of, why should there be this synergy between testability and good design? It's really kind of awkward when you think about it, huh? Why would it be true? Okay, state leaks across tests. You ever have this at all? You're working on a particular thing, and it's like you have a test, and it's passing now, and then some other time later it's not passing. You try to debug through, and you can't see any problem with the code that's being executed. Can't figure out what's going on with things. And then you march through and you do more debugging, and then you discover sometimes it's passing again, and you're not quite sure why. And then you discover later on that you're sharing some static data across the tests, static mutable data, for instance. And when you change that, one test is impacted by another test's actions. Okay? So the state of one test affects another. Is that a design problem? Does it point to a design problem? Well, it does, in a way, right? I'm not going to spend time up here talking about how bad singleton is. I mean, everybody kind of knows now, right? A singleton is an awkward pattern. It's just really it was the way that we kind of snuck global variables into object-oriented programs without going and calling them global variables. And when your professors in computer science told you that global variables had problems, I'm sure you were aware of that, and you tried to go and take that under advisement. The thing that's really kind of cool about testing is it actually goes and makes the pain of global state very real to you, okay? When you're working in code, trying to write tests for code that has global variables, has singletons that have mutable state, then you will discover that your tests will not basically consistently fail or consistently pass. Yes? Yeah. So the question is, wouldn't that be a test smell? And I'm like, yeah, this is a test smell. And all these things I'm pointing out are really test smells in a way. But the thing I'm trying to go and get back to is, it's not really a smell it's a smell of the test, but the reason why it's there is not because there's something intrinsically wrong with testing or intrinsically wrong with the way that you're writing tests. It's because they point to specific design problems, okay? So we know that global state can be awkward, okay? Unit testing makes that global state pain very concrete for us, okay? When we have global mutable state, we need to have some way of going in and changing it. And if we can't really change that, then we're in an awkward state. Even remembering to change it can be kind of awkward at times. Okay, framework frustration. Okay, anybody ever have trouble working with frameworks? Okay? Expected to see more hands because, I don't know, I have lots of trouble working with frameworks. It's funny about frameworks. They often are designed to go and make our lives easier, as I pointed out in the last session. And they're written in such a way that they provide services that everybody can use all the way around the world, and they don't know much about your specific application, but they're supposed to present an API to you which makes it easy for you to do your work. And so framework developers think about this, how to go and make the job easier for you. But the thing that's funny quite often, though, is they don't think about the testability case. And what I've noticed over and over again is that you can go and basically, if you design in a particular way, you typically don't have much trouble with frameworks. And the way that you design is basically by concentrating a lot more on the domain, right? If you concentrate on your domain concepts and try to keep them separate from the use of the framework, then what you're able to do is you're able to go and sort of design things that can be plugged into a framework or delegated to from a framework that are testable by themselves, and you don't have to worry about the framework quite so much. You worry about testing the thing that you're working on. But that really basically sort of requires you to think about thinking about structuring your design in such a way that you aren't using the framework directly. You're having it use you, okay? You create your concepts, you create your objects and stuff like that, and have the framework delegate over to you. And what you're doing is you're getting a real separation between you and the framework. Okay, so one thing I haven't written down here, I have insufficient domain separation. It's just a general thing of separation of concerns. When you have good separation of concerns in applications, design tends to be better. The thing that's interesting about testing pain in this context is that it shows us areas where we don't really have decent separation of concerns. Another place that this happens frequently in web frameworks and in GUI frameworks and stuff like that. You have your code, and maybe you have some kind of an event handler, and you write code in the event handler. And that code goes and does something computationally, and everything is marching along, and it's kind of okay. Fine and everything, except that we discover over time that if we don't really have good separation between our calculations and the things that we're actually using to display things, it's going to cause all kinds of maintenance trouble. What's kind of neat about this is that if you are unit testing, it forces you to get that kind of separation of concerns. You want to take your computation and be able to test it independently of the GUI framework that's using it. And by going and making that possible, you actually are making your design better because you're introducing that separation of concerns. Difficult mocking. Somebody ever found mocking difficult at all? Okay, you're trying to go and mock various things in your code, and it seems like it's painful, and you're doing this and that and the other thing. There's a couple of different varieties of painful mocking in testing situations. The first one here to talk about is you're writing mocks for objects returned by other objects. So you ever work with an API like that? It's like you go to an object and it returns back another object to you, and then you go to that object and it returns another object back to you. You know what it's like to mock those things? It's pretty damn painful, right? Okay, you have to go and create several layers of mocks to do things. Now this is a simple one in a way. What this does do is it points to a specific design problem called the law of Demeter. Okay, everybody aware of the law of Demeter? Have you heard of this at all? Okay, yeah, many of you are. Some of it sounds like you aren't. The notion is that in object orientation, it's nice to go and operate on objects that you own, but it's not nice to go and pass objects that you own back to other people and let them operate upon them. Okay, and when you do that too much, when you end up going and allowing people to create chains of calls, like I go to A and get a B, and I go to that B and get a C, and I go to that C and get a D, what happens is that you really have this pervasive dependency inside the client code. Client code is now aware of A, B, C, and D, and maybe it didn't need to be aware of all those intermediate stages to do the things that it needs to do. Okay? So the law of Demeter is a way of going and sort of maintaining, a way of going and structuring code so that you don't have as many dependencies as you would have otherwise. Those dependencies can hurt you at compile time, right? Force you to go and link against things that you don't necessarily need to link to. They can, though, also hurt you conceptually, right? You have to know about too much in order to do the job in this particular piece of client code. Okay, so that's, an interesting thing. Both of those things are types of pain. The pain is really, really apparent when you're testing, though, because you have to do a lot of extensive mocking when you work with APIs that are like that. Go to an A and get a B and get a C and get a D. Now we got to go to a fake A that returns fake Bs, and the fake Bs got to return fake Cs, and the fake Cs got to return fake Ds. Real, real big pain. We don't like pain. If we try to avoid pain, we can make things better. Okay, and in this case, the concrete pain of going and doing that kind of mocking should tell us that we really don't have a good design yet. Okay, if we're listening. Okay, difficult mocking too. Hard to mock particular classes. Now, it's kind of funny about this. It depends on what kind of tools you're using. But quite often, what happens with this is just, you can look at it and say, well, yeah, it's like I've got this thing I'm touching, and this thing is going to go and talk to a third-party API and all this other stuff. And it's kind of like, it's a pain to mock this thing. And the reason why it's a pain is because this thing is really just a concrete class, right? And if you had an interface for that particular thing, things would be a little bit easier. Implement the interface in one way for your mocking. Implement the interface in another way for your production code. And it seems like a decent thing to do. And that actually goes and does bring your code more in line with what Bob Martin calls the dependency inversion principle. Okay? The notion that when you are working in your code, it's better to depend upon abstractions than to depend upon concrete things. Now, you can't take that a bit far and make abstractions for everything. Make interfaces for everything across your code base. But it's interesting that you have a particular pain that you're dealing with when you're testing. And that particular pain is, I need to be able to go and substitute this particular thing. And I can't very easily. Answer, introduce an interface. And it tends to make the design better than it was previously. Okay, hidden effects. You can't test a class because you have no access to the ultimate effect of its execution. Okay, ever happened to you? Working on a class and it does something really strange and spooky, and it goes and, it touches something outside the system, and you have no real insight into what's happening with this. Now, is that a design problem? It's funny. Trying to find a name for this is kind of awkward. But I think it really comes down to insufficient separation of concerns. Okay, and also encapsulation violation. You should be able to tell by looking at a class, looking at its public interface, really what's going into it and what's coming out of it. Okay? And if there's some secret path that's basically going in, happening inside that class is something that you're not aware of, that's a problem. Some classes, they purely are designed to go and provide an interface to something outside the system, and that's fine. If you have a class which isn't specifically designed to do that, but it does it anyway, that's a big problem. Okay? So it comes down to, again, separation of concerns. If you have, code that goes and accesses a database and does this computation and all these other things, if you separate those concerns into separate classes, your testing is a lot easier than it would be otherwise. And also your design is is nicer than it would be otherwise, because you're able to go and look at each of these things independently and make the changes that you want to in the context of them. Hidden inputs. Not much more to say about that. It's the same type of thing. You're going to something and getting data, and sometimes this is an indication of over-encapsulation, insufficient separation of concerns. It's kind of a funny thing about this, though. It seems like object orientation done right often tends to look a bit like functional programming, okay? In the sense that when you look at something, you should be able to go and see what goes in and what comes out. We all know that objects can hold state, right? They can hold state changes, and that's a bit different from pure functional programming, and that's, that's okay. It's a difference in the paradigm and that sort of thing. But it's interesting to notice that quite often we end up parameterizing things a lot more when we want to go make our design a bit better and a bit more testable. Dependency injection is an example, okay? A lot of dependency injection code tends to look a bit like functional program code in the sense that you are parameterizing things and passing along variants in the parameter list rather than going and having them hidden within the context of the thing that you're working with. Okay, unwieldy parameter lists. Too much work to call a method or instantiate a class because you have too many parameters. Is there a design problem with that? Well, anytime that you have a long parameter list, it's like you're forcing more work on the client. And we can look at that conceptually. We can say, yeah, it's like that looks like it's a bit of a pain, but, it's okay because I'm not the one who's using it. I'm just writing it, okay? But the fact of the matter is, if we write tests for our code, we will feel the pain concretely. We become the first client user of our code, and so we're going to think a bit more about API. We're going to think a bit more about what's easy to do because we got to do it. We got to do it when we're writing our tests. So quite often, this is an indication of too many responsibilities in a class, too many responsibilities in a method, and we can break things down. It's so funny how often this doesn't really occur to people. I remember working with a team a while back, and actually a better example. A friend of mine told me about a team he was working with, and he says, it's kind of cool, but we're doing this TDD stuff, but now we have these really big argument lists, and it's kind of like, well, how big? And he's like, well, for a typical constructor, we have like 7 or 8 things we pass into it. And it's like, TDD is messing up our design. And I'm like, not really. I mean, it's like you should feel the pain of that and find a way of going and factoring your design in such a way where you don't have to pass 7 or 8 things in order to go and create that particular thing. And sometimes it requires a little bit of, moving around and refiguring things and reallocating responsibilities and stuff along those lines. But those things make the design better, and side effect, makes the testing easier. Okay, let's go and we're kind of ending up back where we started. Okay, insufficient access. You find yourself wishing you could test a private method. Okay, this is that one that I mentioned at the very beginning. Over and over again, people want to go and access privates of classes. Every time you do that, look at your class and ask yourself, are there 2 classes that could do the job of this one class? If there was a second class, okay, that made the thing that I want public, what would we call that second class? Can we come up with a decent name for it? And this is particularly a valuable thing to do in groups, okay? Sometimes as a single developer, you're stuck. You look at it and you're like, well, looks like a single responsibility to me. And then somebody else can kind of point, it's like, oh, really, if you had an abstraction for this, it's like that becomes testable. And by the way, look at the design now. It's kind of like, now we have this concept and it makes it easier for us to understand how things are. We can see how things kind of tie together within the context of everything. So typically that indicates too many responsibilities in a class, and we saw how to handle that, going and extracting a class and digging things out. Okay, test thrash. Okay, this is another complaint sometimes people have when they're writing tests for things. They say, okay, I've written all these unit tests, and whenever I change my code, they all break. Okay, so that whole unit testing thing, it's not for me. It sucks. You want me to write unit tests, and they break all the time. Every time I change things. Anybody ever experienced that pain at all? Happens periodically, right? The thing to realize about that, though, is that quite often those are indications of open-closed violations, okay? I don't have a slide up here to go and describe this, so I'll just go and say it in words. The open-closed principle, for people who have not heard about it, is something that was articulated a long time ago by Bertrand Meyer, and it's actually one of the solid principles, okay? And the notion is that basically particular things that you work on, they should be closed to modification but open to extension. And what that means is that typically if you design well, you have lots and lots of classes that you don't have to go back to and change all that often. To go and vary behavior in your system, you just basically go and plug different classes in, okay? Now, there's an interesting relationship between open-closed and single responsibility. As you start to go and make your classes focused on single responsibilities, they tend to just really adhere to the open-closed principle automatically. When you have a small, tight focus, the chance of you having to change that is really kind of minor. That small, tight focus allows you to go and say, okay, well, I can introduce variation by going and changing something with a different focus. Okay, but it's really curtailed to the same particular problem. So smaller classes and methods often give you open-closed as an emergent effect in a code base. But this tends to be true in code bases where you have this thing of like, I need to go and change this one thing, and then all these other things change, right? All these tests break. what you're really, what's really going on with this is that essentially you have changes that are propagating through the rest of the code. And they just, you really don't have locality, good locality of concerns. So when you have that pain, again, it's an invitation to look at your design and go and ask yourself, what can we do to go and make our design a bit better? And if we can make our design a bit better, quite often the testability challenge goes away. Okay, so here's the part of the talk where we start talking about why this is all true. Okay. Anybody have any ideas why this is all true? Why there's a synergy between testability and good design? Is it just one of those spooky, mysterious things about the way the universe is constructed? Ideas? Yeah. Yeah, okay, so the comment is that when we're writing our code, we're kind of shaping our API, and we're basically doing it concretely. So basically, there should be some synergy between goodness and design because we are the consumers of the code. And I agree. I think that's a strong part of it. I think there's another reason also that kind of ties into this, and it comes down to why design is good in certain cases. So why do we want small methods and small classes, assuming that we do? Okay? A lot of this, really, in object orientation is about locality. It's about being able to look at one particular thing and being able to understand, based upon the local context, what really happens, without having to worry about this over here and this over here and this over here. If you don't have to worry about those other things, you can understand something locally and everything is cool. It's easy for you to go and deal with. Now, what's interesting, though, is that tests are really another way of understanding your code. Okay? It's kind of a deep thing when you think about it. It's like when we write a test, what we're doing is we're basically going ahead and we're using an automatic construction to go and basically check particular results, not just by inspection and reasoning things through, but writing code that actually goes and automates this process for us. So we can run these tests over and over again and find out whether things are broken or not broken and stuff like that. So essentially, we're going through the same process. The things which make our code hard to understand mentally often make it hard for us to go and produce automatic procedures for checking those things because they tend to go and kind of fall in line. Okay? There's a paper I was reading a while back, a guy named Tom Mullen, and he was basically going and sort of making this case that good design tends to be good design because it follows cognitive principles. It's kind of like the way our brain works, okay? Smaller pieces make it easier for us to reason about them. As a result, we tend to go and favor smaller pieces when we have a lot of complexity that we go and need to deal with. So I think it's this act of going and trying to write tests and the fact that this is kind of like a cognitive act in a way. It's a way of going and understanding the code that goes and gives us this really extra benefit. It gives us this ability to be able to go and say, look, I can have all these interesting thoughts about design, but if I write my test first, or if I try to write my code, it's an instant, concrete reminder of whether things are actually aligned pretty well with good design principles or not. So I think that's kind of decent, and it's really funny. When you look through things, it tends to kind of pan out pretty well. I'm afraid I don't have the reference with me here. I was going to put it in the notes, but airline lost my luggage yesterday, so it's coming. But I was at the XP 2010 conference a couple weeks ago in Trondheim, and there was an interesting paper there where they took some large projects. They took projects that had done TDD and projects that didn't do TDD, and they started going and comparing the metrics. And one of the things that they discovered is, naturally less complexity, less cyclomatic complexity, smaller classes and smaller methods. And this is without anybody going around to these people and saying, well, this is just a better style of design, do it. They just said, no, please, just use test-driven development. And one of the side effects was you end up with smaller pieces. And typically, that tends to be a bit better for us in terms of going and creating small, flexible things we can compose together to go and solve big problems. So, pretty much saying what I was saying. The one thing I want to talk about also is dependency injection. Okay, I think it's interesting that the dependency injection stuff came up in Java and C#. We haven't seen it in too many other languages like C++ at all. I like to call it the golden hammer in a way because it tries to go and solve these problems in a very forceful way, I say. It's kind of like the notion with dependency injection is that anything that you want to go and produce which has a bad dependency inside of it should be injected through the constructor or set through a setter. Okay? Our dependencies are injected from the outside. We don't create these things internally within our class. They come at us from the outside. And we end up having, some decent design qualities when we do this sort of thing. Are there any downsides to dependency injection, though? Anybody ever frustrated with it? Yeah, okay, it's frustrating. And there's, a number of reasons why. I mean, it depends on what you're doing. In some with some frameworks, you go and you configure things in XML, and that's kind of like, put things in XML files, and you got to load them up, and then it's kind of like you've got this one place where you can go and see all the things that tie together. The one thing I hear about dependency injection quite often that I think is a really interesting complaint is that people say we don't see what the context is anymore. We look at the code, and we see that the code uses some interfaces, but we don't know what concrete classes are attached to those interfaces. So I have this class, and I'm getting an interface, and I work with it, and another interface, and you're looking at the code you just don't see. You don't know what the concrete instantiation of these things is. Now, this is something which is generally true in object orientation if you are using interfaces quite often. And it's very easy to go and get used to this sort of thing because you're kind of like, I understand what variability this gets for me and that sort of thing, and that's good. But when people complain about this, it kind of reminds me of something else. In a lot of object-oriented code, we can very quickly find out what the concrete thing is that we want, that we're actually using in a particular context. We look for the new expressions. In dependency injection code, where we're using it pervasively, quite often we don't have those new expressions. We basically go and get things through interfaces and we work with them. And it feels like in the code that what we're dealing with is we're dealing with a bag of parts rather than a plan for an automobile. Okay? So you know what it's like when you have an automobile and it's kind of like, you can look at it, you can look at the piece of the automobile and it's like, okay, I see a screw here, it's connected to the chassis and this and this and this. And it's like if you look at a plan for an automobile, you can kind of see how things are fitting together. In source code, our source code is quite often like a plan, right? We can kind of look at a class, we can see that this one instantiates that one. We know where to navigate to in our IDE to go and get that particular thing and see what's connected together. Our plan shows us how things are connected. In dependency injection code, quite often what you end up with is that bag of parts thing. You're looking at a particular thing, but you don't really see what's connected to it. Sure, you can look at the configuration and see what happens with it, but it is a bit of a different style. And so I think that's kind of interesting. I think dependency injection is a fine thing, but it's also one of those things, too, where we have to kind of remember that sometimes the explicitness that we have within our code actually goes and helps us out a bit. It helps us go and see how things tie together, and that can make the code a little bit more explanatory. So I think, with this sort of thing, I think dependency injection was a way of going and trying to go and solve testability problems that was useful. It still is useful, but it does lead to particular design effects. Some of them are good and some of them are kind of awkward. So I have this other phrase too. I call them groping test tools, if you ever run into these at all. These are the tools which allow you to touch the private parts, of your classes and everything like that. I have a real love-hate relationship with these things. When you're working legacy code, it can be kind of awkward to go and really break dependencies and tease things apart in a way to go and start to go and move things, around and start to get tests in place and stuff like that. I just really don't like it when people start using these tools for the fresh code that they're writing because now they've got a get-out-of-jail-free card, right? They can eliminate just about all the pain of testing by going and mocking things out through these tools and end up with code that really isn't easy to, easy to test otherwise. But beyond that, it's not just the testability concern. It's the fact that basically they aren't having this force that kind of leads them towards better design also. And I find some value in that. When I'm working on something, I discover that something is painful in testing. Quite often I can say, okay, yeah, the design is a little bit messed up. Well, what can I do? Oh, okay, let me do this. And then my design ends up being a bit better. I think to the degree that we're able to go and learn from our code and actually react to that concrete pain, we're a little bit better off than we would be otherwise. There's a funny story about this. Back in the early Agile days, there's a team I was aware of, and they decided to go and do something interesting. They said, well, for our code, what we're going to do is we're going to have no private variables and no private functions at all. We're just going to go ahead and basically keep everything open in our classes. And we figure that, that'll be okay. We've got tests to go and support us, and we can, we'll be able to test everything. And they marched along like this for a period of time, but what they discovered was they started writing tests that were so tied into the implementations of the classes they were working with, it was really difficult to refactor, okay? Nice thing about classes is that they tend to encapsulate things. You should have more stuff inside and a smaller API outside. When you encapsulate the stuff behind a small API, you've got a place for variation and change, okay? Things you can change without necessarily impacting other things. And so they discovered rather late with this that basically going and allowing access to everything that they had made their testing a little bit too brittle going forward. And the same kind of thing can happen with these kinds of tools. Useful to get out of a jam, but really, I don't know. Pain can be useful sometimes. You ever heard of those people that have that medical condition where they can't feel pain? It's true. There are people who have this medical condition where they can't feel pain. They usually don't live very long, okay? They usually break arms and legs and they're not aware of it, things like that, really serious conditions. So as much as we hate pain in life, we also have to kind of remember that every pain is a bit of a learning experience. And I think it's really kind of cool that we have this thing with testing, that it tends to synergize well with design, and that we can learn a lot by doing our testing. And those things themselves tend to make our design better. So here's the gist of it, really. Okay? Testing isn't hard. Testing is easy in the presence of good design. If you're finding trouble testing things, reconsider your design. You can end up with something better. So any questions or comments at all? Anybody disagree? Yes. Yeah. Okay, so the question is, if you have all these small classes and stuff like that, you must depend upon a DI container in order to go and construct things, because otherwise where would you construct them? My argument would be with this that basically you can just fall back on the new expression, right? In many cases, okay? Sometimes, think about that tokenizer that we were talking about earlier. We had our rule evaluator and delegated to a tokenizer. Chances of us wanting to replace that tokenizer with something else for testing, really kind of light. The reason we wanted to go and extract that out into a separate class was just to be able to go and test it independently. So I have no trouble with my rule evaluator creating a rule tokenizer using a new expression. I don't think that's really a variation point which is useful with a DI container. My problem with DI containers is that I think that they try to solve two different problems, and those two problems get mingled in a bad way. The two problems that DI containers try to solve are making it easier to test and also configuring your application. Okay? So I think that when you're basically going and allowing certain things to be created through a DI container, you have to ask yourself which one you're really trying to do. Sometimes the testability concern can be addressed independently of the DI container. And if that's the case, you may not be getting much added benefit for going and using the DI container where you could have used a new expression instead. Okay? So I think, it's like I said, DI containers are kind of like the golden hammer. And so people are using them, and I think there should be some better practice surrounding them sometimes. Okay. Any other questions or comments? Yeah, where? Yeah. Okay, so the question is, it's like, the questioner was basically saying, we see that in our code. We see this bag of parts thing happening in our code. So the question is, how can we make that sort of thing more discoverable? Some of that is really like an IDE issue. You look for implementers and stuff along those lines. It helps with documentation to go and have some kind of a map of how things are kind of tied together. I do think that we really need to, in certain contexts, basically be aware of where we need to leave hints in our code. And those hints are basically places where we make things explicit. It's funny that we want to have flexibility in our code, but we always have a trade-off between flexibility and explicitness. And explicitness helps us understand how things tie together. So I would look in particular areas for ways of going and sort of making it clear that we are using a particular concrete class because, that is exactly what's going on here, and we should never really need variation in it. And other places where you really do need the variation, so, going and saying, look, I'm going and accepting an interface, and it could be any one of these things. It's like that. I don't think there's any. I think there's any one clear answer for that sort of thing. I think it's more of a tooling issue, and also being very selective about where you choose to use dependency injection and where you don't. So, sorry. Any other questions? Yeah. Well, yeah, okay, so the question is with DI containers, the fact that you can use them to go and manage lifetime and write code where you don't have to care about the lifetime, in the beginning, and you can kind of configure those things afterwards. Yeah, that is an advantage to going and using DI containers. You can do the same thing without DI containers too, as I'm sure you're aware. But it comes down to that thing, and I hate to kind of repeat myself. Sometimes you want things like this to be explicit, and other times you don't. I remember looking at a book a while back, and one of the recommendations they had was to, when you aren't using a DI container, basically use a get instance method to go and get a hold of objects, and that sometimes that was actually creating a new object, and sometimes it was giving you one that existed already. And I looked at that, and I'm kind of like, oh, that's kind of freaking me out a bit, because I'm used to seeing get instance be a singleton method, okay? A method on a singleton, and that's kind of like the naming convention that people have used historically in the industry. The fact of the matter is that there are times when you care whether you're actually creating a new object or whether you're getting an existing one. Sometimes the code doesn't care, sometimes it does. And it comes down to really where you want to make that explicit. And so yeah, no, I agree that DI containers can give you that kind of benefit. But I think that we can't underestimate the amount of thinking work that's involved in figuring out where these explicit points in our code should be in terms of being able to go and make things discoverable for ourselves over time. So. Any other questions at all? Okay, well, thank you very much.